Hello, welcome to chapter 3. This is transforming variables. For this chapter, we're going to be learning how to create indicator variables and change variable classes such as numerics, factored, and ordered, as well as adding or modifying labels, collapsing values for simplicity using the cut-to function, and centering or standardizing variables. So the first topic is applying mathematical and logical operators to variables. The first one we're going to do is a mathematical operator. So as you can see in my first line here, I'm using the example from page 46, and I'm applying the mathematical operator of division to this particular function. So I'm changing the name of states and per capita income to states per capita income dot k. I'm dividing it by 1,000 here. So when I run this function, it gives it here for me. And then I can also run a logical function, such as the one in the second line here, where I can state that this is greater than the mean of all of these states. And what it'll give me down in the console is, without any names of the states, it'll tell me whether my function is greater than the mean of each of the other states. So in addition, on page 47, there's also an explanation of how you can invert a scale for ease of interpretation. And they give an example of NES respondents about whether the federal government should make a concerted effort to improve the social and economic conditions of African Americans, with 1 representing a great deal of support and 7 representing no effort, no support whatsoever. So if we use this function right here, we can take the variable itself and add .rev just to reverse it, and equal 8 because we add 1 to our most, which is 7, minus NES add a black underscore self, which is our variable, and it should give us an inverted score when we present it out. So and there it is. So now we're going to learn how to create indicator variables, which are numeric interpretations of logic statements. Now, if that doesn't make sense this second, it will soon, I promise. So if you take a look at page 48, down in the middle, you'll see this equation here, or this function here. And what we're doing here is we're creating a numeric indicator variable in the GSS veteran variable. So what we're doing with this statement here is saying that any years of service for any veteran in this data set will yield true. So we're going to go ahead and run that one. And then we're going to change this in this function. We're changing it to a numeric function so that true and false values now come up as 1 and 0. So for example, if we were to run this now, it would all be true and false. And now that we run this and run it again, we get all 0s and 1s. So any 1 indicates any amount of service whatsoever. So we now know there are 3 levels or classes of measurement, and those variables are nominal, ordinal, or interval. So we're now going to learn how to manipulate those using R and change them between one another. So we're on page 49, and if you look in my R script in line 22, you can see where we are. We're taking a variable called authoritarianism in the GSS dataset, which is a numeric variable that summarizes GSS respondent support for order and conformity. Its values from 0 to 7, with higher numbers corresponding to more support for authoritarianism. So we can change this into a nominal one just by putting .nom at the end, and we add as factor, easy peasy. And then we can do the same thing to create an ordered factor. And then we can use the class function to check what they actually are down at the bottom. So we do class GSS authoritarianism.nom should get factor for ord should get ordered factor, and for the regular one should get numeric, just like that. Now, if you want to add or modify variable labels, I want to move to page 50 to discuss that. Usually you're going to want to be using a numeric for this, but if you want a factor version in your cross tabulation or mean comparison analysis, which we'll get to in the next couple chapters, you can use this. So we're going to take GSS veteran again, and we're going to make it .f for factor, and we're going to use our as factor function, just like that. And then the next thing we want to do is take a levels function of GSS veteran and label them with this C after the equal sign. So we're changing the labels from 0 and 1 to no and yes. So after you do that, you're going to want to check your work and confirm the variable labels on your frequency. So here, down here, we have no and yes instead of 0 and 1. So that worked. If you want to do something with a few more labels, you can check down at the bottom. There's one on congressional approval. So the first thing you want to do is check what the levels are already. Since I already did this, mine are already set. And then right after that, you can just do the same function and just add the C at the end. And make sure you put in quotes exactly what you want it to say. Put parentheses at the end. And run your frequency to make sure that it worked. And it should look like that. So we're now on page 51, and we're talking about collapsing variables into simplified categories. So we're going to be using GSS age, which is the respondents' ages in years, and we're going to be cutting it into 5 categories. So first, what we're going to want to do is we're going to describe GSS age so that we can see what we're working with. And what we're going to be doing is we're going to be cutting the categories, as you can see, into youngest to 30, 31 to 40, 41 to 50, 51 to 60, and 61 to oldest. And you got to make sure that you use the +1 rule, which is in the book. It says it at the bottom, but I'll just explain it to you now. So in my next line of code, I kind of put it here. You're going to create your cut points for whatever the data you're using are. So because my first is youngest to 30, my first data point is 31 because you add 1 to it. It's the +1 rule. So my next category is 31 to 40, but I put 41 there. My next third category is 41 to 50. That one's 51. Fourth category is 51 to 60, and that one's 61. And lastly, 61 to oldest. So we're going to put 90, so that's our highest value is 89. So once we put that in, we have our cut points. And then as you can see, GSS age 5, age 6 equals cut2 is the name of the function that we're using. And then you're going to do GSS age, comma, cut points. And it should do it right for you. And it applies the cut points. And it creates a new variable. So now what we're going to do is, what I would recommend, is doing a frequency to make sure that you know what you're looking at here and it makes sense. And then you can rename your labels whatever you wish. So you might want to label them what their actual names are, 18 to 30 instead of 31, 31 to 40 instead of 41, etc. And then lastly, we're going to change it into an ordered factor and run a frequency on it. So it should give us clearer labels and a cumulative percent column. In addition, you can also do an alternative way of cutting, which just cuts it into equal size categories. It's called the G argument. So as you can see in number 49 here, I have the example from page 52, and we're taking a variable population urban, and we're cutting it into 5 categories. So we're calling it .5 cat, and this is a world data set. And then you take the cut2 function, and we're taking our world pop urban, and then right here, G equals 5 determines how many different categories we're splitting it up to. Because we're doing 5, we run that, and it should give us our frequency function, just like that. And this also. So lastly, we're going to talk about an additive index. And often a data set will contain several variables that measure the same concept. So researchers will combine them into an additive index, creating a more precise measure of the concept. So a lot of times when people want to use a few different variables that measure the same things, like we will observe shortly with abortion, they measure surveys, answers yes and no with 0 and 1, but they could not mean the same thing. So we're going to see here shortly in our abortion example. So the first, all of these added together are justifications for abortion. So the first question is strong chance of serious birth defect. Woman's health seriously endangered. Married woman wants no more children. Parents can't afford more children. Pregnant as a result of rape. Mother not married if woman wants for any other reason. For each of these variables, respondents replied either yes or no. The yeses all expressed more permissive attitudes about abortion. So to create the additive index, GSS abortion, that's already included in the GSS dataset, each yes response is converted to a 1 using the process for creating indicator variables outlined above, and the 1s are added together. Here's a simple code that reproduces the abortion scale GSS abortion. So we're going to start right there with each of these lines. And when we add yes to them, we add more to this numeric scale. And once we get all the way down and run all these functions, we get down to the abortion scale. And we can add each of these individual functions to the full function. And this creates an additive index for us called abortion scale. So once we run this, there's our frequency distribution.